would be a good opportunity for the panelists to introduce themselves rather than me introduce them. And maybe say a little bit about, obviously the topic of this panel is emerging applications. Maybe say a little bit in a couple of minutes how you are looking at emerging applications in the work that you're doing. Where do you start?
All right. Mike Hobby from Cambridge Consultants, and I'm focused on healthcare and life sciences. And so one of the things my clients come to me with are ideas around how patients can be monitored out in the community, how their health is affected or impacted by what they eat, what they do, how they exercise, whether they sleep, whether they don't sleep, accidents, recovery, waiting for surgery. Everything about them needs to be monitored, and in some cases continuously, and in other cases we are now seeing a push towards processing on the edge. The idea that data doesn't need to be continuously transmitted, only the exceptional data, the insight, the trend, the anomaly. And we are seeing increasing push now for that connectivity to be consistent, reliable, and faster. And in the case of surgery, we see the need for haptic, real-time response, where the surgeon may actually be in another country, actually performing the surgery, happening in a theatre thousands of miles away. So we're seeing a great deal of push on that. We see a great deal around neural stimulation. As our generations are growing older, we're seeing monitoring of cognitive decline, the idea of using neurostim and connected devices to halt that progression. And as we probably know, as a society today, the explosion of diabetes in our societies means that probably around 10% of healthcare now is adopted to monitoring diabetes, new devices worn on the arm, connecting patients to monitor their glucose levels, impacting how they eat, drink, rest, exercise. We see now an explosion of that, not just in diabetes, but in, say, liver function, kidney function, heart function. We see an ever-increasing connected world around health. Thank you.
Thanks very much, Mike. Lot to unpack there, so I'm sure we're going to get into that. Yongliang, maybe you can introduce yourself.
Hello, I'm Yongliang Guan from NTU, Singapore. I'm a full professor in communication engineering from the School of EEE of NTU. I work on coding and signal processing for communication system as well as digital data storage system. Why do I end up in this panel where we talk about applications when you may think that professors work on blue sky research? Yeah. In the past 5 to 8 years, I do have the nice opportunity to work with industry. To name a few, Continental Automotive from Germany, NXP Semiconductor from Netherlands, Denso from Japan, as well as Innolux from Taiwan, among others. So I do have interesting industry projects to share with you today.
Thank you. Peter.
Thanks. Peter Jarek. I head up the GSMA intelligence team at the GSMA, so I think a lot of folks probably know who GSMA is. We're the research and consulting arm there. From an emerging application side of things, really our job is to work with operators, help understand what they need and what the ecosystem needs to support them, but really the whole industry to actually take advantage of these technologies. So from an application side of things, we work with consumers. We go out on a regular basis to survey consumers to understand what they're doing today, what they think they're doing today. Maybe they think they're doing things that they're not. What they want to be doing tomorrow, but then also enterprises. So run a number of enterprise surveys, a big one to understand, again, what enterprises want. We know it's been a big focus for operators. But I think more than that, I think a lot of what we do and we're trying to grapple with it is how those things translate into what we need to do with technologies, networks, things like spectrum, right? We heard there'll be an ever-increasing, more and more data traffic, but where is that data traffic and what type of data traffic and where on the network is that? Is that the edge? Is that in the core? What does that mean for spectrum? What types of spectrum? And so how does that all impact those applications?
Thanks. And Kamar?
Good afternoon, everyone. I'm Kamar Abbasi, Professor of Applied Electromagnetic and Sensing in James Watt School of Engineering, and I lead connectivity team in James Watt School of Engineering. I also work as a policy advisor with Catherine team. My focus, or in University of Glasgow, our focus is on integrated sensing and communication to develop a hardware which is sustainable to do dual features of both communication and sensing. And in that, we are explicitly looking at what Mike has mentioned around changing the healthcare paradigm from hospitals to homes. That how we can have multimodal information collected together, processed our cloud to do proactive detection for healthcare. And that includes ethical constraints, working with end users, working with hospitals, and that is actually changing the paradigm in healthcare domain.
Great. So as you can see, we've got quite a few different dimensions of this topic of emerging applications. And, you know, emerging applications has been emerging for a while. And so it's probably about time we actually start to see some of these applications playing out. So we talk about 6G, but maybe we'll just, each of you, I can go through, get your thoughts quickly on what do you think about 5G? Have we seen any of these applications really come to fruition in 5G? And if we have not, why do you think that is? Maybe I'll go down the line again, start with you, Mike.
Yeah, I think we've seen 5G work with telemedicine. So what we saw through the COVID pandemic is that people were suddenly connecting to their GP, to their hospital, and were using their 5G for their mental health. We're using it for their monitoring of health devices. Wearables has become a thing. We know that wellness and lifestyle devices are now connected to people. You know, if you want to count how many steps you did today, go for it. It's not my thing, but hey, you know, knock yourself out. Wellness devices aren't a medical device, and ultimately they're there for the fittest people and people who are keen to ensure that their health is well balanced. Ultimately, the healthcare industry will embrace the medical device, and I see a lot of those engaging with 5G already. So we already know people walk around with devices that are connecting them either via their mobile. We've seen less direct 5G connected devices, but I think we see in our pipeline of companies approaching us with novel ideas. That's something they want to see.
You're right. I think many of us have applications on our phones, and we can see how that can extend. You're right. Yongling.
I'm from a university. So 5G was used for tele-lecture, particularly during the pandemic lockdown time. So we move all lectures online. And we may think that the students may sit in front of the desktop computer at home to listen to the lecture, but I'm sure more than half of them lie on the bed with their phone. Yeah, and that is 5G.
Yeah.
Yes.
Good observation. Yeah, I think that time of us all staying in our homes during COVID really did boost the connectivity in many different ways, and the way we engage with connectivity.
Yeah.
Peter.
And next, the teleoperation of AV, autonomous vehicle, or the teleoperation of AGV. For example, cleaning vehicles can now be remotely steered and remotely operated. And I have heard from my colleague that 5G definitely works better than 4G because of all the data-heavy sensor communications that needs to be relayed from the service vehicle back to the headquarters, where the operator is steering the vehicle remotely.
Peter.
So, you know, as the one here who runs a team of analysts, we're supposed to be the outside observers, and so you probably expect me to say no, right? And I don't think we have the normal disruptive analysts out there who are going, boo, 5G's been bad. But you know, I would say I think you hit a really good point, Mike, or I think you hit upon something. And I think for me, it's this issue of sort of, I don't want to say, is it directly related to 5G? I mean, all of those devices, all of that connected, those health devices, could we do that over 4G? Sure, right? Did that happen around 5G? Yes. Is it better with 5G? Probably, right? So I would say, have we seen anything disruptive? I'd say from an application side of things, I want to take that in a different angle of, I think we have, right? So if you look at the way we're building networks, we heard a lot about openness earlier today, right? Yeah, you could do openness with 4G, right? And obviously, a lot of the initial work, especially with Open RAN, was not 5G, right? But the move towards supply chain diversity happens when you've got vendor consolidation, happens when you have standards that go towards that direction. So you could say 5G drove things like that. Yes, you have a lot of private network stuff. You have a lot of enterprise wireless taking place with 4G. 4G works great for a lot of applications. But 5G, and I think we heard that early, right, from DT, there was this, maybe we got it a little bit too hyped up, but it really pushed the enterprise angle that I think sees us where we are right now. So I think in a lot of cases, you might not be able to say this is because of 5G or it only can happen with 5G, but I think you can say 5G drove it. And so we are seeing a transformation of at least the way networks are built and the way people are using them.
Yeah. No, I think that's actually a good point. What we've started to see within the 5G time frame may have been achieved with 4G, but you brought up some interesting aspects of how 5G openness can be different.
We tend to forget that when you're spending a lot of money on a network and you're doing something different, there's that opportunity to think of, can I do this different? I mean, if I'm going to launch a completely new network, how should I think about it differently? That's an opportunity 6G presents us going forward, right? But for 5G, right, it brought up those conversations of, should we be more open? And maybe those conversations started too late, right? But I think it's a chance to rethink things.
Come on.
Yeah, so I'm an optimist, so I'll be between yes and no. So actually, I believe 5G had made some kind of transformative impact in sectors like logistics, smart cities, and also manufacturing. So private network enabled machine-to-machine connectivity and enabled use cases like in ports. But the big promises which were being made about telesurgeries, about XR, VR, enhanced experience, those were not met. And the question, why not? We have heard a lot about the standardization issues. In addition to that, slow rollout of millimeter wave was another critical parameter. And also this infrastructure deployment, which is a big challenge. So I think these has slowed down. So it made a bit of impact.
Yeah.
Yeah.
Actually, if I kind of summarize a little bit what we just heard then, 5G has, there's been some, I would say, private type use cases, and we've seen that within the logistics, within ports and trains and other areas. And maybe we hadn't really thought about those as emerging applications. But now if we turn our attention to 6G, and we don't have too distant lens on it, if we start to think about what do you think some of the emerging applications that you can kind of ground within the next 5 years, 5 to maybe 8 years, I know that's far out, but based upon what you're seeing today, and maybe Kumar, I'll start with you. What do you see some of these emerging applications?
So actually, my life has been made easy by the presentations which happened in the morning. So I think one of the key thing would be this global connectivity. Integrated terrestrial to non-terrestrial network can help us to achieve connected the unconnected, which is a big opportunity. Then AI-enabled healthcare, which Mark mentioned, it is another big domain where we want to move from what I mentioned, hospital care to patient care. The idea is that instead of going to doctors, subject stays at home and we have fully connected homes, we have a multimodal sensing coming from, and then we can take proactive detection instead of going to doctors. So that is another big opportunity which I see.
Peter?
Yeah, I mean, I was going to say ISAC, but I think I would probably do myself a disservice and probably look foolish compared to anything you would say. I mean, we do hear a lot. I think when people talk about 6G, what's exciting, what seems sexy or new in terms of new capabilities from technology side of things, we do see a lot of interest in integrated sensing and communication. I mean, it's a really there's a lot of cool opportunities there. I would caution from a business side of things. I think we still need to figure that out and how the business side would work. I think beyond that, also going to that sort of business side or the step down of what we want to do with these technologies. Because I think we heard this morning a few times, and it's a really good reminder, and maybe it's not the right reminder for this sort of symposium. We need to be thinking about the use cases and what we want to do with these things, and not just the technologies, because we're going to get it wrong if we don't. I think to your point about sort of end-to-end universal connectivity, non-terrestrial to terrestrial, definitely seeing a lot of interest there, but with a specific focus on building resilient networks, right? Because circa 2025, whether there's man-made or natural disasters, I think there's a much bigger focus on what that means. And so looking to figure out how we build those networks that are resilient, I think we're seeing a lot more interest. And that's definitely something we should be able to, if you look at the amount of activity taking place in the NTN side of things, notwithstanding the fact that the vast majority of satellites in the sky are controlled by one man who likes ketamine. Not putting that aside, right? I think there's a lot of interest out there in sort of how we build those resilient networks, and a lot of momentum in actually making that work. So I think that's definitely on that sort of 3, 5, 8 year time frame.
Yeah, it's interesting. I mean, the NTN aspect, I think from a timing perspective, comes in that time frame really to change the connectivity paradigm for so many different regions. Right, and we heard a lot from NTT Docomo this morning about plans on the different layers of from HAPS to geosatellites. So I think over a time frame, some emerging applications in parts of the world that haven't had those applications before will become possible. Yongleng, what do you think?
I support Peter. ISAC is also what I'm thinking that could become big in 6G. Particularly ISAC in the form of joint radar communication for vehicles. So I have mentioned that I work with Continental Automotive, and Continental makes and supply vehicular radar. However, vehicular radar works on the 77 dedicated frequency band. When there are many, many vehicles coming on board, that frequency band is going to be congested pretty soon. And you're going to start having false alarm, more and more false alarm, right? On the other hand, a vehicle in future is going to transmit a cellular signal because the vehicle is going to have high performance carputer in there, and it's going to transmit 5G, 6G mobile phone signals, almost like the vehicle itself is a phone user, right? And this cellular signal is going to be reflected by the surrounding. So this signal of opportunity echoes could actually be used as radar echoes to be detected by the vehicle. And therefore, we have done quite a lot on joint radar communication in this manner with Continental Automotive. Then, moving on to maybe drone. I think Magnus from Ericsson mentioned that in future the base station may point skywards because in future there will be flying taxis, customers to serve, right? And that radio could be reflected by any drones, not just the eVTOL flying taxi. And if some of those drones are not supposed to be there, it poses a security concern, then it will make sense for the home team, or the home department of a city or a country to want to detect those. The detection of those could, again, very easily, leverage on the cellular skywards signal because they're going to reflect those signals which can then be detected. So drone detection as another specific form of ISAC could become useful. And finally, ISAC being sensing reminds me of cellular positioning of today. We all know cellular positioning has low quality accuracy, right? Can ISAC improve on cellular positioning? Of course it can. How can it do better? I personally have the interest of making use of RIS, reconfigurable intelligent surface, to support non-line of sight cellular positioning. So these are the 3 types of eyesight that I pay attention to.
Oh, those are great examples. Mike?
I think health-wise, we've always known that screening is the way to reduce cost of healthcare burden on society. So I think what we'll see with the use of 6G is the mobile health screening capabilities. MRI, CT scans, ultrasounds, even endoscopy, going out into the community in mobile health services. With AI on the edge supporting the clinicians so that if you've just taken, I don't know, 300, 400 images of somebody, the AI on the edge is going to reduce that down to the 3 or 4 real significant images the radiologist probably should look at. And that transmitted via the airwaves back to a radiologist wherever they are to confirm that confirmation. And along with that, you've got other things out in the community. Again, neurostimulation we'll see probably be much more utilised. Mental health, so we get into a lot of people's behaviours, their movements, cognitive skills, what they're getting up to. Can we spot, can we intervene before deterioration? And again, the 6G aspect of that means there's a lot more data to take care of. Again, I think edge processing is coming in fast. Somebody I talked to the other day described data. They said 5 years ago you would call data the gold of your business. Today they call it the dirt. There's just so much data, you don't do enough with it. You don't analyze it, you store it mindlessly with Amazon Shared Services, Google, Microsoft. The bill every month goes up because you're increasingly storing more data. And we all heard how we think it's bad to the environment. So the move towards edge processing, dumping the dirt and keeping hold of what the gem is, I think is going to make the aspect of then transmitting that a lot more efficient and a lot more interesting when it comes to then storing that useful insight data.
I actually couldn't have said it better than you did.
Wow.
Yeah.
I'll take that as a compliment.
Edge AI and the leveraging of Edge AI for uplink data, and coming from things like ultrasound and MRIs and X-rays, and being able to provide that at point of use rather than the patient having to come into a facility, which obviously is a huge barrier. I think it's one of just some of the amazing potential that we have now in the not too distant future.
Well, it's a great, I mean, just piggybacking on that, I mean, I think it's a great example because I know we've had some of these conversations, Ronnie, before. You know, one of the things we've seen, and it's kind of frustrating, is on the edge conversation, what's the first word that someone says when you talk about edge? It's always latency, right? Oh, right, you need edge for latency, right? And it's where their mind goes, right? I was excited this year at MWC to see a number of people talking about exactly the latency issue you were hitting on, Ronnie, right? There's the AI, there's the processing and compute latency, which is 5-10 times greater than some of the transport latency. But the reality is, you know, as you said, I mean, edge is important for cost. Edge is important for, from a medical standpoint, data privacy.
Yeah.
Right. It's better if you don't have to send the data somewhere. For resilience, right? What if that connection goes down? What if, God forbid, the AWS or Google or Microsoft's like cloud goes down? It happens every now and then, and you lose those applications, right? Obviously, much better if you can do something at the edge. And I think we're beginning to see that understanding that edge is more than just latency, because that really has dominated the discussion so far.
Yeah, that's great point. Somebody's going to have to keep me honest on time, because I could talk about this for a long time, and I want to make sure we get to the audience questions. So who's the timekeeper for me? You're pointing to. You are? Okay, good. All right. So let's take our rose-tinted spectacles off just for a second, and let's think a little bit about being pragmatic. And what do we think are some of the bigger challenges? We've heard some of the examples, and I think we all agree that those are really valid and real examples. But what are the challenges in achieving those? And maybe I'll start in the middle this time. Yongliang, what do you think?
Okay. I would like to mention about NTN service. One of the challenges that I can think of will be the regulatory control or the regulatory framing of NTN. Nowadays there are a lot of scam call centers, and we know that many of them operate in the border of Thailand and Myanmar. And in the recent past, what the Thai government has done is to cut their power and cut their telecommunication services as well as mobile services. However, they are still operating. And people found out that they make use of Starlink. They make use of Starlink. So, so they are great technology users, advanced technology users. So coming to think about this, when NTN service goes online massively in the future, maybe the regulatory control have to come in so that in such cases, someone can actually do something about the situation. Of course, the NTN itself is good. We can provide remote educations to remote areas of a country. That is without a doubt.
Yeah.
Yes.
That's a good point. Regulations, I think, with things like NTN, we've seen obviously that certain companies control some of the satellites or a company, and that takes control away sometimes from regions. Peter, you...
No, I think the NTN point, and I mean the fraud and scam issues, I think if anyone out there has not paid enough attention to this, it is just the amount of fraud and scam and some of the life-changing consequences of this. It's not just people losing some money sometimes, it's indentured servitude that in some regions actually, so it's a huge, huge issue. On that point, I think just keeping with the NTN side of things, there is an issue when you have companies that maybe operate transnationally, particularly because what are those regulations? A national operator might be regulated in a certain way. Those regulations might not apply to the satellite provider. So not only do you have issues like that in terms of skirting some fraud issues, but just unfair playing field, right? If one operator in a market has to do certain things, provide certain services, lawful intercept, whatever else, and another one comes in and doesn't, I think that's something that we're going to have to start thinking about. But I would say, sort of pivoting a little bit, we know that there can be huge value to some of what we're talking about in terms of spreading coverage from to new places to uncovered areas. I would say the other thing I think we're going to need to think about from a challenge side of things is a little bit of an ethical side of things, because we know that anytime we launch new technologies, we always hear sort of people who are maybe a little bit optimistic saying, great, can we have undeveloped regions leapfrog? Right, they're going to go straight from 3G to 5G or straight to that. Just please don't. Just please don't. I mean, you're going to look foolish. It's not going to happen, because that those new UEs will always cost more to begin with before scale is there, right? And the new equipment will. So we're never going to start, or you're not going to see that leapfrogging, but you may see leapfrogging in terms of new capabilities. And it was a few years ago, ran a workshop with a number of operators about it was a strategic sort of view of potential scenarios for the future. And how do we think about regulation and technology development? And every single group across 4 different groups, the one thing they all had in common, increasing digital divide. Right? No matter how you saw the future going, more regulation, less regulation, more value of digital services or less, the one thing everyone said was going to happen is increasing digital divide. And I think we need to make sure that as we look at new 6G technologies, that they don't sort of add to that even more.
Yeah, good point. Kamar, what do you think some of the barriers are?
So I think we have challenges in 3 domains. It's ethical, regulatory, and technical domain. If we talk about ethics, we talk a lot about AI. So the bias in AI, which is coming more and more often, is a big ethical issue. And then when we talk about autonomy, how much autonomy we want to give to systems in mission critical application, for example, defense, healthcare. When we talk about regulatory issues, we are hearing from the morning these standardization issues. And then for NTN, cross-border data sharing, it's very important in terms of regulatory compliance issues. And if we come to technical issues, I work a lot, by the way, on ISAC, so that's why I didn't said that it's a big open challenge. But in ISAC, one of the big technical issue is to make a hardware which can do both sensing and communication. If you talk from operator and vendor perspective, deploying a totally new hardware costs a lot. And in terms of technicality, making a transceiver which can do sensing and communication in same frequency band at the same time, at a low speed, at a very high bandwidth, it's a big technical challenge. So we have so many challenges in all aspects.
Yeah, good. Well, life wouldn't be great if there weren't challenges, would there? Mike?
Healthcare challenges, so many. You could leap to the obvious, you could say privacy, but that's been there for a long time, and that's a bit obvious. I think the challenge actually is the corporate healthcare industry. And when I say corporate, I think when we try to describe AI, we've almost got to that point now with, oh, don't mention AI again. They've almost got saturated with the message of AI, because it's not, AI is just a broad term and it has so many connotations. Foundational AI, agentic AI. Nobody in corporate world quite wants to drill down into that level. And so there is a sort of almost mindset now of, yeah, but how safe will it be? Will it affect my business badly? Am I going to get litigation problems later? Is it going to leak out? How do I control it? The EU, as we know, is nervous about it. UK is a little more entrepreneurial, and America is more probably gung-ho. But what we have seen is real concerns from large corporate medical companies who are almost paralyzed by not knowing how to utilize AI and communication, to the extent that they're stalling because they can't see a route through the ethical maze. And I think one of the conversations I'm having now regularly with them is the idea of foundational AI on the edge, almost developing something very small, manageable, that they can take control and ownership of, allow it to learn and develop, give it then some, kind of lever. We go from training it to lever 1, which is now it can assist, and then we push to lever 2 and it says, actually, I can guide, and then maybe we go to lever 3 and it says, I'll actually diagnose for you. And that might take 10, 15, 20 years, but we have to have that conversation now, because corporate world is, I think, is stalling at this very crucial stage. And I think what we'll see is startups and engaging new brains and less fearless operators come into the marketplace and grab it. And then you'll see a sweep of mergers and buyouts as corporate then wants to take it on board.
I think one of the things we always see is when you see these types of challenges, yet they're really opportunities that drive you to want to solve the challenge. It's often the innovation of startups that get you there faster, and whether they end up getting acquired or whether they end up standalone companies, that can be a good source of pushing through those challenges. Yeah. So we talked a little bit about healthcare. We might come back to that if we have time, but I do want to spend a moment on education, because that's another area where we potentially could have a benefit of some of these emerging applications and connectivity. Kamal, probably no better place to start than you on what do you see in education?
I think 6G has a huge potential for, I think we're running short on time.
No, you're good.
Okay.
Go ahead.
Okay. It has a huge potential in terms of training and education for sectors like healthcare, for aerospace. We can get extended reality to help us to get training with low cost. In terms of education, if we want to connect an unconnected or overcome digital divide in education, 6G with NTN can provide access to remote areas where we can provide remote education, either in terms of lectures or in terms of lab access, which we have seen from Japan in the morning about this Internet of Senses, but that concept can be applied to education as well. So I think there's a huge potential in that space.
One of the things we've been seeing at NVIDIA a lot is this ed tech adoption of AI and personalized tutoring, for instance. You know, sitting in a classroom full of 30 students, not every student's going to learn at the same rate, and you can leverage AI to do personal tutoring. How do you see that layering into 6G in ubiquitous connectivity?
So, okay.
Go ahead.
So I think this point I missed, but this personal tutoring and providing personalized feedback for education is very critical nowadays, because our last 20 years we have changed a lot in terms of education sector, where personalized feedback is more important than providing an overall feedback, and that comes under pastoral care for student, and student nowadays have totally changed as well. So this AI enabled tutor provide self-learning for this education sector, which is changing quickly and helps student to learn new things fast as well.
Okay, I think we have about 15 minutes left. So maybe it's a good time to open it up to the audience. If you're chomping at the bit to ask some questions, go ahead.
Test. Yes, thank you for the inspiring panel. We are talking about 6G, yet I think we shouldn't write off 5G. Magnus Frodik this morning was mentioning that 2025, 2035, the next 10 years is the 5G era still. So my question to the panelists is that, let us fast forward 5 years, 6, 7 years, early 2030s. What type of applications and use cases cannot be realized with standalone 5G? For instance, there is a lot of discussion in the panel on AI edge. Again, why would we need a new 6G standard for those applications?
So maybe I'm going to just point that first to Mike.
Okay.
Go ahead.
I mean, certainly the ability remotely to send detailed, complex images from the points I raised earlier about CT scan or MRI, but also in the terms of photonics now, with photonic sensors looking and monitoring for cancer markers, tumor degradation, tumor shrinking, circulatory tumor cell. There's a great deal of information that can be gathered there with photonic, and which I think requires a sort of more broader 6G requirement in terms of getting that data captured and transmitted and reviewed, looked at, confirmed, contacting the patient again, and then sort of the diagnostic side, I think, for me.
Yongleng, do you see anything maybe even in the area of, I'm not going to,
Yeah, I was going to mention
smart spaces or
maybe post-quantum crypto, support for post-quantum crypto. I do not think that that is part of 5G. So if it can be embedded into 6G, then the mobile adoption of PQC could become smoother, when 6G comes.
Yeah, come on.
So I have a very good example to add, which we work on, basically holograph with senses. So up to now, we can teleport only 2 or 2.5 senses from point A to point B, which is hearing and vision, which is by phone, and then a bit of haptic as well. But imagine if we can teleport all the 5 senses from point A to point B, including smell and taste. So we can have a real sense-based hologram on the other side, where we need actually ultra low latency, ultra high reliability, which 5G or private 5G cannot do it. Because for example, if I want to teleport touch from point A to point B, 1 inch square of a hand needs around 1 gigabits per second of data. And imagine a complete hand, multiple hands. So this needs huge amount of data with ultra low latency, which is not achievable by 5G or whatever we can see.
And I think that's the short answer, I think, across all of these, right? The short answer is just more data, right? I mean, you're sort of looking for specific use cases. I think it's a question of whether it's AI, whether it's XR, and it was good to see someone talk about the metaverse, although we don't call it metaverse anymore, right? Whether it's XR, whether it's sensing, whether it's just more and more data. Now, I would put a bit of a caution there, right? I mean, I think there is a lot of discussion around the impact of AI on networks and networks for AI. I think there is still a question of what that looks like, particularly as we do more and more processing at the edge, on-device AI. What will that impact actually be on network traffic? But you take that, you take the sensing, you take everything combined. I think it just really comes down to just more data. I mean, we heard the comment earlier on in one of the earlier questions. History teaches us, right, that there will be more and more traffic across the networks. That really just is it's not a sexy answer, but it's really the only one.
Great, thanks. Another question? Yeah.
Kin Leong, Imperial College. Thank you very much for your insights. I have a question as follows. I know that I'm attending a 6G symposium, and I'm not on the payroll of IEEE, but I would like to ask the following question. I wonder whether when we think about 6G emerging applications, whether we should think about including IEEE, let's say 802.11 standards and services in mind. Because I thought for 6G to be successful, especially from a deployment and service operators perspective, they have to evaluate whether their deployment would justify the revenue they're going to come in. And if the service is going to be supported by 5G or IEEE 802.11 Wi-Fi or future version of Wi-Fi, then how much 6G investment would be actually realize the benefit from it? So in thinking about the applications, for example, we are talking about medical application. I understand, but most of the time, people are in their home when they see their doctors. So they are in a stationary environment. And that of course, depends on how their Wi-Fi router are connected to the internet. But if they're connected through, let's say, wire network, then 6G may not play that role into that. I just wonder how.
That's a really good question. In video, we went through this thought process a while ago when we were looking at edge applications, and we realized that if you have cameras in a retail outlet, they could be Wi-Fi connected or Ethernet connected. Why does it require cellular connections? So maybe Mike, do you have an opinion on that?
Only in that, I'm not that qualified to answer some of those questions, but certainly ambulatory and in terms of militarily, deploying mobile capability is really one of the driving forces around that. Also in terms of societal threat to terrorism attacks on health, and the ability to respond to that in a rapid and engaging way that removes the risk as widely as you can. The need for 6G coverage in those areas where a lot of data is going to then be required very rapidly and in a very coordinated way is probably where I would see health needing that. So yeah, that's probably that's my answer, I guess, on that.
Yongling, do you have a comment?
I was thinking about one particular scenario where both the cellular and the Wi-Fi standards are competing with each other, namely the V2X, vehicle to everything, 5.9 at 5.9 gigahertz. Many of us know that particular communication, V2V communication or V to infrastructure communications, has two international standards. One is based on IEEE 802.11p and 11ay. The other is based on cellular V2X, side link communication. Both are pushing ahead their own agenda. Recently, a new development has occurred. The NCAP, Vehicular Safety Rating, NCAP, New Car Assessment Program, that gives a vehicle its safety rating. That NCAP is region-based. The Euro NCAP has put DSRC, which is the IEEE version of V2X, into the Euro NCAP 5-star rating roadmap. The China NCAP has put in cellular V2X into their 5-star, China NCAP 5-star rating roadmap. So I'm just wondering, in this particular field, whether there is a need to harmonize. If there is, then perhaps both organizations could come together under a suitable umbrella. And there is a suitable umbrella, which is the 5G AA, 5G Automotive Association. So yeah, this is my thought. They could come together to harmonize.
Great, good point. Do we have time for one more? Yeah, 2 more questions. Okay, go ahead.
Yeah, sorry. Thank you. Yeah, Dan Warren from Samsung. So one of the things which has held back a lot of use cases in 5G is associated with risk, and I was pleased to hear Doug just mention, Mike just mentioned risk in his last answer. Is a new generation of technology the right approach to deprecating risk in use cases, or should we be focusing more on 5G?
Who wants to take that?
Yeah. I can take it. So let me give you an example from this healthcare perspective. So one of this paradigm shift is around integrated sensing and communication. And we have this healthcare not only in indoor scenarios. So we have scenarios where we are shifting from indoor to outdoor. We wanted to localize the target. So the granularity provided by this 6G for sensing will not be provided by 5G. So ultimately, by adding 6G elements like reconfigurable intelligent surfaces, we can have high localization, tracking, and sensing, which is only possible through 6G.
I can give you a nasty example of sort of risk, if you like, in technology and health. And that was where people with insulin pumps and mobile phones were being hacked in the States. And there was a deliberate attempt to overdose people with their insulin.
Well,
so you could say that there's very much a need for improved security around those systems. It also was a risk because the FDA are struggling to work out, as is the EU, how you license the closed loop system, because you've got software controlled by a patient, you've got a pump, you've got something going into the human body, it's all interlinked, and that's caused them a real combinational headache in terms of actually certifying such a device. But the risk to hacks and outside activity to cause harm with these devices is a very real threat.
Yeah, we didn't really come on to the subject of security and resilience, well, security in particular and encryption, but ubiquitous connectivity of many things opens up many more attack surfaces. Okay, last question, I think.
Can I ask, because I think the applications are really exciting and we all want better healthcare and we all want more affordable healthcare systems. Can we do better as an ecosystem at expressing the role that connectivity plays in that value chain? Because I think quite often there's a focus on the AI or on the end application. If we think the connectivity is essential, what more do we need to be doing to express the value of that? I guess in the sort of commercial world, but also maybe more broadly through research into policy.
Yeah. So, in video we talk about intelligently connecting intelligence, which is kind of a new way of having intelligence in the connectivity. But maybe Kumar, you want to?
So I think connectivity is the neural system for, let's take an example of healthcare system. So Mike mentioned that we are now in a connected world where we have sensors around us everywhere. So how those sensors will bring data to the edge or cloud, that is connectivity. And the amount of sensors we are getting in the world, the amount of data and bandwidth we need is actually enabled by 6G, which cannot be covered by 5G so easily, considering so many other constraints?
Well, I guess it's a good question. The obvious answer is yes. Can we do a better job? But I mean, here's kind of the problem, right? We were thinking about this just the other day of think about the history of connectivity, right? And the mobile industry as part of that. Back in the 2G and 3G days when this was new and people were getting connected and there were all these new things, this was really cool, right? Telcos, mobile operators, they were at the center of all of it. That's great. Now, pretty much everyone's connected, right? And so it's kind of like, can we do a better job of talking about the value of plumbing to making universities work? I mean, you would not have a university without plumbing, right? But no one talks about how critical it is to making 6G, the role of plumbing in 6G standards. I mean, maybe someone should do that, right? Electricity, right? We don't think about electricity. It's just there until you realize maybe your grid can't support new AI workloads. So, I mean, I do think the answer is obviously yes. How you raise that to sort of say, this is sort of a utility now, but it's more than utility, and make people realize that we need to value it. I think the answer is obviously yes, but there's a reason why.
Yeah. So if I may add.
Oh, sorry. Go ahead.
So making these connectivity more energy efficient, bringing renewables to it is another important thing where we can do better.
So the two things which I think you referenced to is patient pathway, which is often what's referred to the journey from screening to diagnosis all the way through to post-operative treatment. And the other one is the digital record. And both of those have interoperability problems. You know, we call ourselves, well, we're very lucky in the country here, we call it the national health system. There is nothing national about the way that data is stored, I can assure you. So I think one of the things around connectivity is actually being able to take that patient data right through their pathway through to recovery and back into society as a contributing member of society. And that connectivity has problems all along it, which needs sorting.
Harold, I've been told no more time, but I think you have special dispensation.
Sorry, I'm feeling guilty. A follow-on question simply. So that question, there's a lot of discussion, at least in this country, about productivity in industries, in vertical industries that do things but not most efficiently. And how do we communicate or help those industries to be more efficient and offer communications as a solution? And how do we create sort of an ecosystem of fail fast, allowing ideas to be tested in industry, allow them to fail, but also allow them to succeed? I think we are not courageous enough to get things out. How do we break that sort of block of moving away from technology but looking at solutions and help in the industries?
Okay, you opened up a question that can take a long time to answer. So
no lunch for anyone. Lunch has been cancelled.
Okay. So I think what we're going to do, Harold, if it's okay with you, get your answers from the panelists, because I think we have to stop now.
A couple of minutes.
Oh, okay, all right. So maybe Yongling, I'm going to turn this over to you because you didn't have a last comment on the previous question. Do you have an?
Yeah, it's difficult for me to comment on that. I'm sorry.
Okay. Peter, anything?
I think in terms of failing fast, it depends upon where you are in the ecosystem, right? Operators have a difficult time failing fast, just sometimes based upon the business model and based on the regulations. Building solutions that allow folks to fail fast, I think, is key. Something you hit on, though, that I don't think is recognized enough, and it kind of goes back to the earlier question, is the value of what takes place with the digitization of enterprises and of industries to things like sustainability, right? We've been talking a lot about that, right? We so much focus on, when we look at these technologies, what can we do to make the network more efficient? If you look across all of telco and mobile networks, it's like 1% of the electricity consumed, right? If you add cloud, you're maybe adding an extra % there, right? It's not a lot. The impact you can have on sustainability from that network by actually digitizing another industry is immense, right? Much more than you can do by a couple extra percentage points of improving the efficiency of a network. So I think there's a real value there if we can do it right.
I think in healthcare, you've got ambulatory, you've got A&E, and you've got unplanned care. Push that to one side, deal with that, focus on how that's run. now look at predictive, preventative, screening, diagnostics, and allow that to run more like a business, I would say.
Kamal, you had a
Yeah,
comment.
if I just add, so I think it's mindset and cultural change which needs to be done to be basically not risk averse and be brave enough to agree or ready to fail. And for that, I think industry academic collaboration anchored by government to support them that, okay, do it, we are behind you, will lead us to success.
Yeah. I think that's a great comment to end on, actually. It's the government, academic, and industry coming together and building those minimum viable products that can immediately show the potential of an innovation. And if it doesn't work, accept that that's okay. Yeah. Okay, well, I'd like to thank the panelists very much for their time tonight.